You know that little speaker in your phone? The one that wakes you up, plays your favorite songs, and lets you hear your family from miles away? We use it all the time. But have you ever actually stopped to wonder how that tiny, tiny thing makes such a big sound? Well, today, we're going to dive into the absolute engineering marvel that's packed inside your pocket.
Okay, to really get a sense of how wild this is, get this. The entire speaker assembly, the thing that produces all that sound, weighs about the same as a single US dime. I mean, that is ridiculously small, yet somehow it can fill a whole room with music.
So that's the big question, isn't it? How in the world can something so incredibly small and lightweight create sound that's so rich and complex and powerful? Well, the answer is this fascinating high-speed dance between physics and some seriously precise engineering.
To pull back the curtain on this little magic trick, we've got to look at its anatomy. We need to see what it's made of. So let's dive in and break down how it all works, piece by piece.
When you get right down to it, there are basically four main players doing all the heavy lifting. You've got the diaphragm, the voice coil, the magnet, and this really clever little part called the spider. Let's kick things off with the part that actually creates the sound.
So first up, we have the diaphragm. The easiest way to think of it is like a tiny, flexible piston. It's this super thin, stiff piece of material, and its whole job, its only job, is to move back and forth really, really fast, pushing the air around it. This is literally where sound is born.
Now, the principle here is actually pretty simple. When that diaphragm pushes forward, it squishes the air particles together in front of it. That creates a little pocket of high-pressure air.
And then, when it snaps backward, it leaves a little space, right? A pocket of low-pressure air. And it's this constant, super fast cycle of high and low pressure that creates the waves that travel through the air and into our ears.
And we are not talking slow motion here. Not even close. This thing is vibrating or oscillating thousands of times every single second. Each one of those tiny, tiny movements creates the exact frequencies and volume that we hear as music or a voice on the phone. It's just mind-boggling.
Okay, so the diaphragm moves. Got it. But it can't move by itself, right? It needs some kind of engine to drive it. So what's the motor that's making it move so incredibly fast and so precisely?
Well, that power comes from this brilliant team-up between our next two parts, the voice coil and the magnet. Together, they form this tiny, powerful electromagnetic heartbeat for the speaker. So first, you've got the voice coil. It's pretty much what it sounds like, a tightly wound coil of super, super thin copper wire, and it's physically attached to the back of that diaphragm we just talked about. Now here's the cool part. When your phone sends an electrical signal through that wire, poof, it instantly becomes a temporary electromagnet. Now, that temporary magnet, the coil, is sitting right next to a really strong permanent magnet, usually made from something called neodymium. So you see what's happening. You've got two magnetic fields right next to each other, one that's always on and another that's constantly changing based on the electrical signal from your music.
So here's how that little engine really works. The audio signal from your phone is just an electric current that's always changing. As that current flows through the coil, it creates a magnetic field that's also always changing. And this changing field is constantly being either repelled by or attracted to the permanent magnet. It's this non-stop push and pull force that moves the coil and the diaphragm it's attached to back and forth at those insane speeds.
So we've got the part that makes the sound and the motor that drives it. But think about it. With all that crazy fast movement, things need to be perfectly controlled. If it wobbles even a tiny bit, the whole thing could just destroy itself. And that's where our final component comes into play. It's called the spider. Yep, the spider. It's this thin, flexible, but really strong ring that holds the whole assembly perfectly in place. Its one and only job is to make sure all that powerful movement happens in just one direction, perfectly forward and backward, with absolutely zero side-to-side wobble. Honestly, the best way to think about the spider is to picture a trampoline. The springs let you bounce up and down, but they also keep you from flying off the side, right? And they always pull you back toward the center. Well, the spider does the exact same thing for the diaphragm. It allows for that perfect piston-like motion and then snaps it right back to its neutral position after every single vibration. Okay, so now that we've met the whole crew, let's put it all together. Let's see the entire symphony, from an electrical signal all the way to a sound wave actually hitting your ear. So here it is, the whole process in 4 quick steps. 1. An electrical signal from your phone turns the voice coil into a magnet. 2.
That magnet interacts with the permanent magnet, pushing and pulling the diaphragm. 3. The diaphragm's movement pushes air, creating sound waves. And 4. All the while, the spider keeps everything perfectly aligned and centered. That's it. That's the symphony.
That's the real takeaway here. The concept itself is elegantly simple. Just use electromagnetism to move air. But to shrink that idea down to the size of a dime and make it work thousands of times a second with such incredible precision, that requires a level of structural complexity that is just, well, it's breathtaking.
And it kind of leaves you with a cool thought experiment, doesn't it? We just established that sound is the organized vibration of air particles. So, that begs the question, what's the real difference between that and just wind? Something to chew on the next time you crank up your favorite song.